Hello everyone, I'm Taekyung Lee. Under the guidance of Professor Lee Suk-jung, I will talk about our presentation that is distributed photovoltaic generator. Before, I'd like to quickly introduce my team members, 주엽, 임, 준영, 박, 수정요. They are so pretty, aren't you? Agenda includes background research goal, method, schedule, and the location. First, I will explain the principle of photovoltaic generators. Photovoltaic generator converts sunlight into electricity by using the photoelectric effect. Next, I will present about the trend of photovoltaic generators. I'd like you to look at the graph on screen. You can see that domestic renewable energy production is increasing. Also, this graph shows the annual renewable energy generation by 2030. In December 2017, the government announced the Renewable Energy 3020 implementation plan aimed at increase the proportion of renewable energy to 20% by 2030. The government's plan suggests that power generation will continue to rise until 2030. This graph shows the power generation under conditions such as solar, wind, hydropower, and among them, solar power is the most efficient. According to this graph, the power generation of renewable energy in Korea is increasing every year. Among them, solar generators have the best rate of increase. As the interest in solar power increases, government support for household generators is expanding. Therefore, the marketability of household generators is getting better. However, household generators are currently less efficient due to some problems.
My name is Sujong Yu, and I will keep going on to this topic. Next, I will present the problem of existing home photovoltaic generator. First, limited space makes hard to expect enough power generation. Solar generators receive sunlight and generate electric. Therefore, the amount of power generation immediately varies depending on the areas of sunlight received. Therefore, generators in factories install in large areas, but household generators have limited space, making it difficult to expect enough power generation. Secondly, present solar generators efficiency is not a maximum. Also, power generation is depending on the position of the sun. If the sunlight enters vertically, the power generation is maximum. So many factories have been equipped with tracking system that follow the sun to produce maximum power generate efficiency in solar power generator. But this tracking system of generator makes generator have heavy volume and weight. Also, it's hard to maintain. So it's hard to install in limited space like home. Finally, power generate efficiency is fluctuating by photovoltaic panels temperature. Well, if photovoltaic panels temperature is 25 degrees, then power generate efficiency is decreased 0.5% when the temperature rises 1 degree. Even in summer, panels temperature rises up to 70 degrees. It means the efficiency is not that high, even although the maximum solar power in summer. Existing solar generator use expensive thin film solar cells to reduce this heat, so this makes generators price higher. I'd like to move on to the next topic about our approximate design objective to solve this problem. First, We will design the generator considering the spatial utilization. Secondly, we will try to lower the temperature of solar panels. Finally, we will use silicon panels. Existing solar panels have used expensive monocrystalline panels to increase efficiency and space utilization. It leads to high generators prices. However, if we use silicon panels, we can reduce cost of increased efficiency.
I'm Julia Bim, next presenter. I will talk about our ultimate goals. We made layout focused on the spatial characteristics and efficiency. As you can see, layout on the left side we made appearance by using SolidWorks, and on other side is panel which used for production. We make a product with 3 panels on each side for spatial efficiency. And using the convex cylindrical lens, the sunlight received from the outside is close to the lens in one focus and distributed as much as possible. The concentrated sunlight will incident on the cylindrical lens, fit into the mirror and spread uniformly. In addition, the cylindrical lens will be coated to prevent excessive heating by incident only 300 nanometers to 1100 nanometers, which are solar wavelengths, and we will be optimizing with apply various shape of lens and mirror. And the next page, I want to talk about a specification that is targeted to improve uniformity and spatial efficiency of the product. Since solar panels have the best efficiency in which light comes in as vertically as possible, we will design the lens to match the sun, which change the meridian transit altitude. So, we set a goal of 90% when the uniformity is vertical to the angle of incident of sunlight and 75% when it's 10 to 14 o'clock. As mentioned above, we set an energy target of each panel per hour. Assuming that 1 watt of sunlight came in, we set a target of 0.7, 0.9, 0.75 watts, respectively from 10 to 14. And the most important thing is mirror will be made to reflect more than 90% of the reflection, and the design will be carried out the incident angle of sunlight entering the mirror can be 20%. In addition, 400 kilowatts per square meter electricity will be produced in order to have higher power generation than existing LG's monocrystalline solar panels, and the size will be produced using online products. To minimize efficiency reduction due to heat generation of the product, it is designed to facilitate convection circulation of air so that the temperature of the panel does not exceed 50 degrees. And the material of the lens will be made of PMMA or aqua.
I'm next presenter Junyoung Park. Now I will make a presentation about research method. We will use an optic design program named RightTools to design and focus on gaining high uniformity. Regardless of the incident angle of sunlight, our product has a high uniformity for efficiency. To do that, we will design an optic system that combines various shape, mirrors, and range. Also, we will design to minimize volume and weight. Next is the overall schedule of the research. As you can see in the table, this schedule is show approximately of all process until the final presentation, and it may change. Through the patent and thesis on solar power generation in January or February. we looked at the principle of generator and the latest technology trends. At the same time, we are working on optical design of lens and mirrors. In addition, we will simulate the products designed from March to May directly to the sunlight, adjust the range error or luminous energy by changing the shape of lens and mirror. Also design the confirmed case from FA while considering the product. After manufacturing the product, we will actually measure it from May to June and check defects in the product and then compare to other products to evaluate its performance. Finally, our team divided the roles to do their best in the respective roles and working efficiently as you can see in the table. Soo-jung Yoo and Taekyung Ri for pre-survey and report writing, and Joo Bim and Junyoung Park for lens design and simulation. Joo Bim and Junyoung Park design appearance and production. Also the budget and schedule management are Soo-jung Yoo and Junyoung Park. And the production of lens will be outsourced. In addition, Joo Bim and Taekyung Ri decided to write the thesis, and finally, the performance evaluation will be divided into Soo-jung Yoo and Junyoung Park. That brings us to the end of our presentation. Thanks for your interest and attention.